Hello and welcome to the slide presentation and introduction to Robustica. Before we start the presentation, some background. Robustica was developed after it was realized that many technical professionals who were able to appreciate the value of probabilistic methods and robustification found the theory and the application overly demanding. Because these same people were typically skilled in the use of spreadsheet software, it was decided that a probabilistic add-in to Microsoft Excel would make an ideal tool. While other add-ins were available at the time, they were typically based on Monte Carlo, and it was found that they were unsuitable for the process of robustification. Therefore, it was decided to develop an add-in based on a more suitable process, error propagation. This add-in became known as Robustica, a Microsoft Excel add-in that effectively gives you, the Microsoft Excel user, the skills of a probabilistic designer and an ability to robustify your designs and strategies. To demonstrate the use of Robustica, we will consider the simple example of a pyramid, which is covered in the user guide. Here we can see a drawing of the pyramid and the functions used to predict the volume of the pyramid and the conditions under which the pyramid will tip. For this case, it is desired to minimize the random variability of the volume and reduce the probability of the pyramid tipping when it is tilted at an angle of 10 degrees. To use Robustica to optimize a system against the effects of random variability, that system must first be modeled in Excel. Here we see an image of such a spreadsheet for the pyramid case. Notice that for each of the input variables, both the mean and the standard deviation have been specified. Further, you will also notice that cells have been allocated to the mean and the standard deviation for each of the output variables. Finally, notice the Robustica toolbar at the top left-hand side. Once we click the first button in the Robustica toolbar, we are presented with the input-output form that we use to specify the inputs and outputs to Robustica. What we see here is the specification of the first input variable with a normal distribution. Once all of the inputs have been specified, we need to specify the location of each output cell and where we wish to have Robustica place the respective mean and standard deviation. We also need to specify the failure modes, both soft and hard, for each of the outputs. Once the inputs and outputs have been specified, we are able to predict the mean and standard deviation for each output. This is done by clicking the second button in the Robustica toolbar. Now, note the moments that Robustica has calculated and placed in the specified cells at the bottom of the spreadsheet model. At times, we wish to know what the major sources of random variability are. By clicking the third button, we are presented with a contributions chart. This chart tells us which inputs contribute most to the random variability in the outputs. In this case, the major source of random variability seen in the volume comes from the length and the width of the pyramid. We now know that by controlling these variables, we will get the greatest improvement in quality. Robustica calculates the moments of the outputs with greater speed than the majority of other competing applications. However, this is not the primary purpose of Robustica. By clicking the fourth button in the toolbar, we are presented with a robustification form. Here we specify the settings of the genetic algorithms that are used to find the best combination of nominal values for the input variables to reduce the effects of random variability. This can be called robustification, design for Six Sigma, or parameter design. What's important, though, is that without any extra effort being directed towards the control of the input variables, we will have a system that exhibits improved quality. After robustification, Robustica presents us the spreadsheet model with the optimum input values. In this case, the random variability of the volume, expressed by its standard deviation, has been reduced by more than 30%, and the chance of tipping has been practically eliminated. While robustification is of enormous value, Robustica has one more feature. Robustica can find the optimum combination of input variables for a series of target values for a given output variable. This is expressed as a curve called the efficiency frontier. All we need to do is press the fifth button and then select the output of interest along with the desired accuracy. This is the frontier for the volume of the pyramid. We can see from this that as the average volume increases, the standard deviation increases in a linear manner. Such information can be useful in other cases. For example, will a business venture become riskier if we pursue a higher returning strategy? Or what will the effects be when we change the nominal output value of a subsystem within a complex technical system? Therefore, Robustica gives you the ability to now consider the effects of uncertainty when making those higher-level decisions that have significant and long-term effects on product performance and business success. This slideshow has used only a simple case to show what you can do with Robustica. However, Robustica can be used to reduce randomness effects in the various technical and commercial situations you encounter. And of course, never forget that you can contact us if there is anything you would like to discuss. Thank you for your time. We hope you now have a greater appreciation of Robustica and what it can do for you.